Okay, so we're caught up. We just finished up week 1 and week 2. Now we're moving on to week 3, and then by Thursday, we can just move on to the current week. And I think we'll all be on the same page here. Okay. So let's go into the week 3 homework. Biodiesel. Okay. So figure 3.3 on page 48 shows a max yield of about 98% for an alkaline catalyst concentration of 0.7 by weight. We looked at that in last week's lecture. Calculate the amount of lye in pounds necessary to react with 100 gallons of peanut oil. Use 0.910 grams per cubic centimeters as the density of peanut oil. So let's go ahead and look at that solution. Okay, so let's run through this together. So what we're looking for is how many pounds of peanut oil. So we know we've got 100 gallons. So we're just going to convert. We've got the volume. We've got the density. We've got a conversion factor, a volumetric conversion factor, and a mass conversion factor, and then we end up with a mass. So let's just go ahead and write that out longhand. Make this note a little smaller. Bring this guy up a little higher. Okay, so 100 gallons. Gallons, and then we've got the density is 0.910 grams per cubic centimeter, and then we've got 3,785.4 cubic centimeters per gallon. And then we've got 1 pound per 454.5 grams. Equals, so the gallons cancel, the centimeters cancel, the grams cancel, and we're going to be left with pounds. So just going through the arithmetic, 757.9.
I got 768, but I just looked up this was the weight of a gallon of peanut butter.
Oh, okay.
757.
757.
768, but
Yeah, that's
I'm
really
still way off with the amount of lye that we're going to put on there for some reason.
okay. So now I'll get into the next one.
What is a chemical? What is the triglyceride composition of peanut oil?
What's the triglyceride content of peanut oil? Well, actually, I don't really know that off the top of my head. It's probably pretty, fairly complex. It's probably, it's going to depend a lot on even what species of peanut you're using. And I don't think you have to know that to answer the question. I think it's just sufficient to know that.
You demonstrated it last week.
Well, yeah, when we were doing the full stoichiometry, we did need that because we needed a molar ratio. So max yield of about 98% for an alkaline catalyst, concentration of 0.7% by weight. So we're coming in with 757 pounds of peanut oil, and so we're aiming for 98% yield. So we're going to use 0.7% of how, so whatever. So really, we're just looking for 0.7% of 757 pounds. That's really all it comes down to. It's just as simple as that. So let's just finish this problem off. So the problem states that the mass of lye per mass of peanut oil equals just 0.7%. So from there, really all we're doing is taking 757.9 pounds, multiply that by 0.007 equals, so 757.9 times 0.000, nope, not too many O's. 757.9 times 0.007 equals 5.3. That's all the question was asking. So there it is. Alkaline catalyst concentration of 0.7% by weight. So we knew how many gallons we had. We converted that to pounds. We took 0.7%, which is the same as multiplying by 0.007, and said just need 5.3 pounds of lye to hit that
Can you read
reaction.
that first line, because I'm very confused with that.
This right here?
Yes, she's matched.
Sure.
90% for alkaline catalyst concentration of 7% by weight.
Yeah.
I guess that would be 7% lye by weight.
Exactly. And so, again, I mean, one of the easiest ways to look at this is to draw a picture. So here's your peanut oil, big old vat of it. We know we've got 100 gallons of it. We just weighed it, and we know that the weight equals 757.9 pounds. Now the question, and you've got this little bucket of lye over here, and when you stick some of it in there, you're going to get your biodiesel out. The question is, how much lye do you put in? And if we go and look, let's just take a look on page 48. Yes, this is a nice little cookbook. So the picture is showing that at 0.7, there's a maximum up here. And that maximum is, well, I can't read the number, but it's just shy of 100%. And what we're also showing, there's a nice little sweet spot. If I don't add enough lye, I don't get as much yield. If I add too much lye, I don't get as much yield. So the sweet spot is right there at 0.7%. And the problem states that's by weight. You know, it's not by volume, it's 7% by weight. So we first had to convert the 100 gallons to a weight. And now then the question is, well, how many pounds of lye do we put in? Well, running that little equation, 757 times 0.0% gives us 5.3 pounds. So 5.3 lbs goes in, and then your biodiesel comes out at 98%. All right, well, that is all I've got for this week. We've covered weeks 1, 2, and 3. I will go ahead and grade grade everything. Make sure you've got credit for all your homeworks, and we'll dive into week 4 on Thursday.
There's one question on the week 3 test.
Oh, you want to look at that really quick? Okay, we can do that. Is that okay with
Before
you,
you jump
Jonathan?
What? Oh, no problem.
Just take one more?
Hey, no problem.
Couple minutes? Okay.
So, I think it's
Tell me when you see it.
it's 3.
The acid value is a measure of the amount of free fatty acids present in oil feedstock. If the acid value of a candidate oil is less than 4, which transesterification process would you use?
I thought it said more than 4.
I'm just going to guess off the top of my head.
No. That's more than 4. Acid would be more than 4. The check does nothing for you.
Oh, does it?
I have not found even, I guess, can you end the question now?
Well, let's
There's an end question sign?
let's take a look.
Oh, you can add a question, I see what you see, it's outline transesterification. I thought it said more than 4. I answered right.
Alkaline.
Yeah, because if you look at this first slide on page 49, acid catalyst transesterification of less than 4 substantially anhydrous values greater than 4 occur with reduced drastically alkaline catalyst reacts with the high feedstock to produce the soap water.
Yeah, well, so a high pH is alkaline and a low pH is acidic. So low pH is an acid, high pH is a base.
Yeah.
Yeah.